In this session, we're going to discuss pigeonhole principle. So under this topic, under this section, we're going to discuss the principle and the generalized principle of pigeonhole. So basically in pigeonhole, it says we determine how we're going to organize our data, our item in a container. So in this example, we have a pigeon, and how are we organize? Are we going to organize it in the holes? Okay. So in this example, one hole contains one, and another hole contains two pigeon. So basically, in pigeonhole, it determines the arrangement, how many item in number of holes, or it determines pigeonhole principle also determines the worst case scenario in defining or in meeting the requirement of a certain scenario. Okay, so for example, how we're going to get three colors, three the same colors in a um in a basket, okay, or how we're going to get piso in our wallet. Okay, five five pieces of piso in our wallet. Okay, so pigeonhole principle could help us. Okay, in determining the scenario to meet that requirement. Okay, so for example, so if a flock of 20 pigeon roost in a set of 19 pigeonhole, one of the pigeonhole must have more than one pigeon. So this is correct. Am I right? Kasi if we have 19 pigeons, let's suppose everything will be um, um, everything will be filled up by one pigeon. Okay, and then the excess will definitely go to one pigeonhole. So therefore, one pigeonhole contains 20, and the rest contains one pigeon. But that is the one scenario that we have. There are others that no, there are some hole doesn't contains pigeon. Okay, and what is the effect? If one hole doesn't contains a pigeon, therefore it will go to another pigeonhole. So in this example, in this pigeonhole, instead of having one, we have three. Here's the two. Here, three. Okay. So based on this, okay, we could say that at least one, okay, one hole contains more than one pigeon. It could be two, it could be three, it could be four. Okay, so this is true. Okay, and through the pigeonhole principle, we determine a certain rule that is applicable to all arrangement. Okay, how we arrange the pigeon to our holes. Okay, this is always true. Okay, so through pigeonhole, we could get the distinct characteristic of that arrangement. Okay, and through that, we could determine. Okay, so we know the desired result. So using pigeonhole, we could get the number of regions, the number of containers to meet our requirement. Okay, so basically the pigeonhole principle, if k is positive integer and k plus 1 object are placed into k boxes, then at least one box contains two or more objects. Okay, so the container is less than the number of objects that it could hold. That's the pigeonhole principle. And we could say that at least one, more than one, okay, more than one object in one container, or at least two object in one container. That's the minimum. That's pigeonhole principle. Okay, so let's have this example. Among any group of 367 people, there must be at least two with the same birthday because there are only 366 possible birthdays. Okay, so in this example, 366 possible birthday. So worst case scenario, the first 366, they don't share the same birthday. So it means the 366 days has already been occupied by the first 366 people. So on the 367 people, a person rather, so definitely it will fall either of the 366 days that we have. So it means it, okay, so it justify the statement at least two with the same birthday. Okay, so 366 they don't have the same birthday, but on the 367 person, so one of them is the same with the last person. Okay, so that's pigeonhole principle. Okay, so to generalize our pigeonhole principle, if n objects are placed into k boxes, then there is at least one box contains at least. So this symbol, if you forgot, this is ceiling. Ceiling means round up. So it means ceiling of n divided by k objects. Okay, round up of n divided by k objects. So if your n is 100, okay, in this example, among 100 people, there are at least, okay, 12 in a month. So 100 is your n, k, your container is 12 months, so 12. Okay, so ceiling of 100 divided by 12 is equal to 9. So it means we have 9 persons that belong to the same month or born in the same month. Okay, among the 100 people in our set. That's pigeonhole principle. Okay, it defines, okay, the relationship of the population and then the criteria and how we're going to group it. Okay, another example. How many cards must be selected from a standard deck of 52 cards to guarantee that at least 3 cards of the same suit are chosen? So in our deck of cards, we have 52 cards. How many suit do we have? We have 4. We have club, flower, club, yeah, club, spade, not flower, club, spade, heart, and diamond. And each suit contains 13 distinct cards from ace to king. Okay, so we need to define the scenario, okay, that will tell us, that will give us at least 3 cards from the deck of cards, will give us 3 cards of the same suit. Okay, so we're going to answer this. So basically, okay, so from the 52 cards, hindi yung 52 cards ang i-consider natin. So just part of the cards. So we're going to determine the worst case scenario. Okay, so with the formula, the pigeonhole, and is undefined pa muna. Even though we have the total 52, hindi 52 ang gagamitin natin. Kasi we have a scenario wherein may specific tayo na dapat 3 suit. So hindi 52 ang consider natin. Part of 52 cards lang. So that's why n muna siya. Okay? So ceiling of n divided by the container, which is 4, and the number of items in a container, 3. Okay? 3 cards of the same suit. Okay, so it could be 3 hearts, 3 diamond, 3 clubs, 3 spade. Okay, So this will be our equation. N will determine the number of deck that you need to pull from the deck of cards, from the 52 cards. Okay, so ceiling of n divided by 4 greater than or equal to 3. Okay, so to solve this, okay, to solve this, so it means yung 3 natin dito is not the real 3 since we use ceiling here. So the original integer is 2. So we subtract 3 as we subtract 1 from 3. So that's why it becomes 2 here in solving for n. 2, okay, again, we consider only the integer part of the result of ceiling of n divided by 4. 3 is the round up. So therefore, the original value is 2 point something. So that's why we're just going to use 2, okay, times the number of containers, 4. And we all know that n should be higher than the container so that it will yield or it will run up to 3. It should not give us 2. It should be 2 point something round up 3. So that's why we add 1 here. 2 times 4 is 8. If we are going to divide it by 4, it's just 2, which is not equal to 3. Okay, so 2 times 4 plus 1 is equal to 9. 9, okay, this should be less than, greater than. So ceiling n over 4, 9, ceiling of 9 over 4 is less than or equal to 3. This should be less than or equal to 3. Okay. So what is the answer of this? Okay. So 9 divided by 4 is 9 to 1/3. Ceiling, that's 3. So therefore, the number of cards that you need to get from the deck of cards to have, okay, 3 of a kind, okay, 3 suits, okay, same, 3 cards of the same suit rather. So we need 9, okay, 9 cards drawn from the card. So just to visualize, kasi pwede mangyari would be the worst case scenario, 2 clubs, 2 spade, 2 heart, and 2 diamond. So in total, we have 8 cards na. So definitely on the 9th card, when we get the 9th card, so it means one of the 4 suit will be 3 cards of the same suit na. Okay, so for example, we get heart. So now, originally we have 2. On the 9th card, we have heart. So it means we have 3 cards from heart suit. Okay, so the worst case scenario to get 3 cards of the same suit is 9, drawing 9 cards. So it will definitely get 3 cards of the same suit after the 8 or on the 9th card. Okay, so that's the principle of pigeonhole principle. You define the worst case scenario to get the desired result. Okay, so that's it for the pigeonhole. Thank you for listening. If you have any question, kindly send me a message, please. Thank you.